Come solve with me the AP Calculus AB free response test, question 1. An invasive species of a plant appears in a fruit grove at time t equals 0 and begins to spread. The function c defined by c of t equals 7.6 arctan of 0.2 t models the number of acres in the fruit grove affected by the species t weeks after the species appears. It can be shown that c prime of t equals 38 divided by 25 plus t squared. And know that you will be needing to have your calculator in radian mode, but lucky for us, I will be using decimals to help visualize what is happening here. The point of this question is rate of change, because it is telling us the initial state of the fruit grove with c of t, and how it's changing through time with c prime of t. So c of t can be read as the acres affected in t weeks. Now part A says, find the average number of acres affected by the invasive species from time t equals 0 to time t equals 4 weeks. And we need to show our setup for our calculations. The question is asking for an average, and in calculus the integral gives the total accumulated quantity of something, and dividing that by b minus a spreads the total evenly over the interval. So here we introduce the average value formula, where the average value equals 1 over b minus a integral from a to b of c of t dt. Since our interval is 0 to 4 weeks, then a is 0 and b is 4. The integral equals the total area under the curve, which is synonym in this case for the overall impact over time. And the average value equals typical number of acres affected over the 0 to 4 weeks specifically. Now let's rewrite it with our function. And we have the average value equals 1 over 4 minus 0, integral from 0 to 4 of 7.6 arctan of 0.2 t dt. Using a calculator, this evaluates to approximately 2.778 affected acres. And visually, this is how it looks on decimals. Part B says, find the time t when the instantaneous rate of change of c equals the average rate of change of c over the time interval t bigger or equal to 0 but smaller or equal to 4, and show the setup for your calculations. The derivative c prime of t gives the instantaneous rate of change, which was initially already given to us, and we use the average rate of change formula c of 4 minus c of 0 over 4 minus 0 because it gives the overall change in c over an interval, interpreted as the slope of the secant line from 0 to 4. And we get that t equals 1.282008. So we're finding the point where the tangent line slope equals the secant line slope. And now the derivative of ct was initially given to us, and if we set the instantaneous average rate of change equal to the average rate of change, we have this equation. Evaluating this on the calculator will give you this number. And you don't need to do all the algebra for the AP Calculus test if you're allowed to use a calculator, but I will give you a quick rundown of the process. So the first thing we want to do is to distribute, and we do that by multiplying this number by 25 and then by t squared. Now this is our updated equation. And we want to isolate t because we want to find t. So our next step is to subtract this number on both sides. Now that we have subtracted on both sides, now we can divide by this number on both sides as well. We're almost done, and all we have to do now is to take this power of 2 on both sides. And when it goes to the other side of the equation, it becomes a square root. Also, we can simplify the division, and we take the exponent of both sides, and that's how we find the result for this question. Assume that the invasive species continues to spread according to the given model for all times t bigger than 0. Write a limit expression that describes the end behavior of the rate of change in the number of acres affected by the species. Evaluate this limit expression. Here, rate of change is referring to the derivative, so we're working with c prime of t. And the end behavior means we want to know what happens to c prime of t as time goes on forever. That is, as t becomes very large. So we write the limit of c prime of t as the limit of 38 over 25 plus t squared as t goes to infinity. Now let's evaluate. As t gets larger and larger, t squared also gets larger and larger. In fact, t squared grows without bound, meaning it goes to infinity. So in the denominator, we have 25 plus t squared. The 25 becomes insignificant compared to t squared because t squared is so large. Essentially, the denominator is becoming an extremely large number. That means we're taking 38 and dividing it by a huge number. And when you divide a constant like 38 by a number that keeps growing toward infinity, the value of the fraction gets closer and closer to 0. So the entire expression approaches 0, and therefore the limit is 0. And this means that over time, the rate at which the number of acres is increasing slows down and approaches 0. At time t equals 4 weeks after the invasive species appears in the fruit grove, measures are taken to counter the spread of the species. The function a, defined by a of t, models the number of acres affected by the species over the time interval of t between 4 and 36. At what time t, for the interval of t, does a attain its maximum value? So in here we're being asked to find when a of t attains its maximum value on the interval we're given. And to do this, we first find the critical points by taking the derivative of a of t. And from the fundamental theorem of calculus, the derivative of the integral gives a prime of t equals c prime of t minus 0.1 ln t. And this is because differentiating the integral removes the integral sign and replaces it with the integrand evaluated at t. Next, we find when a prime of t equals 0, since that's where we can locate critical points. So we have 38 over 25 plus t squared minus 0.1 ln t equals 0. Also, for this question, we can either substitute the given expression for c prime of t or just use the calculator like Desmos in this case. And a prime of t will look like this. T is approximately 11.4417. Now we check whether this value gives a maximum. We compare values of a of t at the endpoints and at the critical point. At t equals 4, we have a of 4 is approximately 5.128. At t 36, we have approximately 1.743. And at t equals 11.44, we have approximately 7.317. We can also see this visually using a graph of a of t, which shows a peak at t approximately equal to 11.44. Since a of t increases up to t approximately equal to 11.44 and then decreases afterward, this point is a local maximum. Because it is the highest value on the interval, it is also the absolute maximum. Therefore, a of t attains its maximum value at t approximately 11.44 weeks.